Welcome, stargazers. Could you at any point trust it? Picture a heavenly occasion so monstrous that it creates shaded areas on Earth, apparent indeed even out so everyone can see. That is the scene we may be near, the precarious edge of seeing in the Orion heavenly body. The star Betelgeuse is acting strangely, indicating an approaching cosmic explosion blast that will illuminate our sky more than ever. However, when will Betelgeuse go supernova and what will it look like? As indicated by researchers, what secrets could this heavenly occasion uncover? Join us as we delve deep into the subtleties of what's actually the deal with Betelgeuse and the effect it could have on our planet and perhaps the whole planetary group. Found roughly 650 light-years from Earth in the heavenly body Orion, Betelgeuse isn't simply any normal star. It's a red supergiant, perhaps one of the most brilliant stars known to us, sparkling with a brilliance north of 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not just for its splendor, but also for its history and importance in human culture. Named after the Arabic expression Yad al-Zawiya, which means the hand of Orion, Betelgeuse has been noticed and recorded by ancient civilizations for hundreds of years. It has been a guide for voyagers and a mark of marvel for stargazers, with its ruddy shade distinguishing it from other stars in the Orion heavenly body. Can you imagine a solitary star overshadowing our whole solar system? To give some perspective on the Kepler supernova, the sheer size of Betelgeuse, if it replaced our Sun, would stretch its edges all the way to Jupiter. How could a solitary star at any point achieve such epic extents? At 10 million years old, it's much younger than our 5 billion-year-old Sun. However, Betelgeuse's monstrous size means it consumes its materials at a much faster speed, forecasting a more limited life expectancy than that of other stars. Now, the divine behemoth, traversing a volume sufficiently larger to contain over 1 billion of our suns, is approaching an incredible finish. When stars of such extent reach their sunset years, they don't just disappear. They make a dramatic exit, a cosmic explosion blast that is beyond human comprehension in terms of energy and brightness. Such an occasion has the potential to eclipse a whole world, creating shaded areas of brightness across immense cosmic distances. The last time Earth saw a cosmic explosion blast this nearby was in 1964, long before the development of modern telescopes. This event, known as the Kepler supernova, was the last cosmic explosion to be seen in our Milky Way with the unaided eye, remaining visible for over a year and a half. It was more brilliant than any other star in the night sky and surprisingly stayed visible during the day for quite some time. What secrets do these heavenly remnants uncover for us? Ancient records from various human civilizations, including Chinese and European astronomers, reported the appearance of this new star. Interestingly, what secrets do heavenly leftovers uncover? Remnants of this blast in the structure of a growing gas cloud can still be noticed today with refined telescopes, giving us insights into the violent endings of massive stars. Cosmic explosions have been uncommon for eyewitnesses on Earth, but imagine a heavenly explosion so intense that it rivals the splendor of a full moon, creating shaded areas on Earth around evening time and being visible during daylight. The radiation from such an occasion would charge our atmosphere, potentially influencing satellite operations and perhaps even the climate. Betelgeuse, with its capricious dimming patterns, suggests it very well may be preparing for just such a stupendous scene. Might we be on the edge of seeing one of the universe's most sensational occasions? Recently, space experts made a startling disclosure. Between October 2019 and mid-2023, Betelgeuse underwent an astounding change that drew the attention of stargazers and enthusiasts globally. Known as the Great Dimming, the star's brilliance, which had been predictable for a long time, began to decline significantly. This unexpected change was noticeable to such an extent that even casual stargazers saw it while comparing Betelgeuse to other stars in the Orion star grouping. This implies that we're not only hundreds of years from seeing its cosmic explosion blast, but perhaps just a few years or even less. By April 2023, astronomical observations revealed that Betelgeuse had returned to its normal radiance levels, leading many to believe that the time of inconsistency had ended. In an amazing turn, the following months saw Betelgeuse's brilliance intensifying by a surprising half. Such notable fluctuations, while normal for variable stars, were strange for a star like Betelgeuse, which had predominantly shown predictable glow cycles. The abrupt and extraordinary flood in its brilliance pushed the star back into the spotlight. Why did Betelgeuse throw a divine curve, igniting conversations about its potential fate? What caused this unexpected change in brilliance? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly exhibit such erratic behavior? Stars are not just shimmering dots in our night sky. They are dynamic substances with life cycles, activities, and secrets of their own. For some celestial bodies, occasional splendor varieties can be expected, much like the beat of Earth's seasons. Throughout its heavenly lifetime, Betelgeuse has maintained a relatively predictable 400-day radiance cycle. However, with the Great Dimming, it appeared to challenge its established behavior, testing our understanding of the celestial phenomena above. Now you may be wondering, are we very close to a heavenly disclosure? While the specific explanations behind Betelgeuse's anomalies are still under investigation, a compelling hypothesis has emerged. This hypothesis posits that heavenly activity and mass ejection present an interesting scenario. Picture Betelgeuse as an epic celestial volcano, quietly emitting and removing a tremendous amount of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had previously expelled an enormous amount of its surface material into the universe. This ejection, a stupendous event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, impacting its apparent brightness and temporarily making it significantly harder to observe. Then, as this dust began to scatter or was blown away by the power of the star's radiation pressure, the cover lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that is not finished surprising us. Many theorize that Betelgeuse may be moving toward the twilight of its life. So, what is a cosmic explosion? A cosmic explosion is an astounding explosion of energy that can dominate a whole universe in an instant. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from an adjoining star or, in Betelgeuse's case, from the depletion of its atomic fuel, which causes its mass to overflow into the core, setting the stage for a catastrophic breakdown. Yet what drives an enormous star like Betelgeuse to its end? Born from the gravitational collapse of gas within atomic clouds, stars like Betelgeuse launch their process by consuming hydrogen in their cores. This initial stage, known as the main sequence stage, lasts for billions of years and forms the spine of a star's life. As a star runs out of hydrogen, it advances, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to consume helium, leading to the production of carbon and oxygen. This transition from the main sequence stage to the helium-consuming stage is marked by the star's venture into becoming a red giant. Over time, as helium reserves diminish, the star undergoes further development, shifting into other consuming stages, each characterized by the fusion of increasingly heavier elements. The greater the star, the faster these advances happen, given the tremendous gravitational tensions at play. Then comes the peak when iron begins forming at the center. Unlike lighter elements, iron does not release energy when fused, so the energy produced isn't sufficient to resist the star's own crushing gravity. The star inflates in size and undergoes a collapse, followed by a massive rebound effect resulting in the explosive power of a cosmic explosion. So is Betelgeuse near the very edge of an explosive end? Ongoing research by Japan's Tohoku University suggests that the star may be in its carbon-consuming stage at the moment. Lead specialist Hawk believes that the core could implode in a couple of years. Is Betelgeuse near the precarious edge of an unstable end after its carbon reserves evaporate? However, not all researchers agree. Contrasting studies from Hungary's Konkoly Observatory estimate that Betelgeuse is still in the earlier helium-consuming stage. The one thing that researchers do agree on, regardless of these discussions, is that Betelgeuse is scheduled to become the Milky Way's next cosmic explosion. Yet, nailing down the timing of this occasion remains an inestimable guessing game, with wagers ranging from just a few years to 100,000 years. Amidst these scientific debates about Betelgeuse's destiny, one fact remains unchallenged: the very nature of our perceptions when we gaze toward the brilliant cosmos. There's an unpretentious oddity we often disregard. This mystery is rooted in the actual concept of time and light in our vast universe. Stars and celestial bodies are so far away that their light takes time to reach our eyes. For example, the speed of light, while a bewildering 186,282 miles per second, still has its constraints. Consequently, the light from remote stars and galaxies takes time to navigate the immensity of space before it graces our sight. Looking at Betelgeuse, you're really seeing a scene from 650 years in the past. To put that in context, when this light set out on its journey toward Earth, the Renaissance was just unfolding, and travelers like Marco Polo were making their mark in history. Each perception we make of Betelgeuse is like looking through an infinite time capsule, granting us insights into its far-off past. If, for argument's sake, Betelgeuse had already detonated in a grand cosmic explosion, we would remain unaware for an additional 650 years. So while we examine and foresee its impending cosmic explosion somewhere out in the vast universe, this amazing occasion may have already unfolded. We're simply waiting for it to navigate reality until it arrives at our eager telescopes. The ongoing discoveries surrounding Betelgeuse have led to intense conversations in the cosmic community, with correlations being drawn to another thrilling discovery: SN 2023X. This recently observed cosmic explosion occurring in a galaxy neighboring the Milky Way reminded many of the intriguing elements and eccentric nature of the universe. SN 2023X was unique in its own right, found a few million light-years away. It exhibited an extraordinary display of brightness that quickly surpassed its host galaxy. What made it especially fascinating to researchers and casual spectators alike was its uncanny resemblance to what many anticipate will be the fate of Betelgeuse. The energy, power, and outcome of the blast offered a tantalizing glimpse into the cycles that these gigantic stars undergo as they approach the end of their life cycles. For some, SN 2023X served as a preview of if and when Betelgeuse meets its hazardous destiny. The sequencing of events might look similar to what was observed with SN 2023X, and the connection between these two celestial occasions highlights a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant cosmic explosion such as SN 2023X, these enormous phenomena remind us of the dynamic and evolving nature of space. Beyond the visible and scientific, the blast would have significant consequences for human culture. The sky, noticed and worried over for centuries, would change, prompting reflections on transience, the vastness of infinite time, and our position in the universe. Such vast miracles help us remember the ephemerality of existence and our timeless journey to grasp the extraordinary. As we contemplate the potential cosmic explosion of Betelgeuse, it's essential to understand the broader ramifications of such an occasion on our cosmic neighborhood. When Betelgeuse finally reaches its unstable end, it could impact not just our immediate surroundings in the Milky Way but also the dynamics of the interstellar medium. The shock waves produced by the cosmic explosion will create tremendous districts of ionized gas, enriching the surrounding space with heavier elements formed during the star's life cycle. This interaction plays a vital role in the grand cosmic cycle of matter, fostering new stars and planets with the essential elements for life. Additionally, the light from the approaching blast could act as a wizard research laboratory for cosmologists. Observing the light curve and spectral features of the cosmic explosion could provide phenomenal insights into the life and death of massive stars. Every cosmic explosion offers a great look into the physical processes at play, revealing how energy is conveyed in such destructive occasions. By focusing on these phenomena, researchers can refine their models of stellar evolution, adding to our understanding of the universe's life cycle. In addition to scientific advancements, a cosmic explosion can have social repercussions. Historically, significant galactic events have influenced art, literature, and philosophy. The splendid appearance of Betelgeuse would likely inspire a new wave of creative expression and reflection. Individuals across the globe would look to the night sky, contemplating their place in the universe. This event could spark a renewed interest in astronomy and science, similar to the curiosity that emerged during the Renaissance when astronomical observations began to reshape how we perceive the universe. From a practical outlook, the impacts of a cosmic explosion could extend to technology. Increased radiation levels from such a blast could present challenges for satellite communications and navigation systems. These ramifications would require advancements in protective and defensive technologies, further pushing the limits of engineering in space exploration. As we continue to depend increasingly on technology, grasping these astronomical events becomes vital for mitigating their effects on our everyday lives. The cosmic explosion could also alter our perspective on time itself. The transient nature of such an event reminds us that even the most enormous celestial bodies are not timeless. This acknowledgement may inspire philosophical discussions about existence and the transient nature of life. The universe operates on timescales that dwarf human existence, yet we find significance in our brief moments under the stars.